Good day, everyone, and welcome to our session to learn how OSRAM Continental created an intelligent plant. With me today is Andre Wagner, Head of IT Operations, and he was and is the project manager for our MES implementation. And as Chris pointed out, we will answer any questions after the presentation. So, Andre, please.
Yeah, thank you, Sebastian, for your warm words and the introduction. And also thank you, Chris. Yeah, I would like to present our project to you. So please learn how OSRAM Continental created an intelligent plant. So, but at first, let me introduce myself. You can see me on the video. So, and here are also a picture. So my name is Andre Wagner. I'm the head of IT operations and manufacturing applications at OSRAM Continental, and I have more than 16 years IT automotive experiences with Continental and also with OSRAM Continental, especially in the field of production IT infrastructure, implementing and operating several different manufacturing execution systems, designing, implementing, and also operating business intelligence solution as well as data lake solutions. So, but at first, what is OSRAM Continental? So the headline, OSRAM Continental, the future of automotive lighting. I think this fits really good to our mission because we develop innovative automotive lighting systems. We are a joint venture between the name, let's make it already clear, between OSRAM and Continental, and we are combining lights, electronics, and software to create solutions for better visibility, efficiency, and functionality. To our product portfolio, we count LED front lighting solutions, rear lighting solutions, interior lighting as well, and our new path of development is projection. As you can see here, some example pictures. This is our development path forward. We want to use the projection solutions to make the world a little bit more safer, so that you can inform other road users about risks in front of your car by using this technology. Yeah, but now let's go to the project we started together with SAP, and let me tell you how the journey began. At first, to the initial situation, so that means where did we start? So historically grown, the MES topic is and was not well defined. So it greatly varied from production side to production side. Means in detail, each production site had its own MES solution. So, and this is for sure a big disadvantage, because if you want to implement a new product, a new machine or a process, then you have to do this more than one time, and this is a waste of money, and you have to spend extra effort there. And this was the starting point for us to say, okay, let's start with a benchmark. Let's check the market for good solutions for a globally standardized MES system for all production locations. And we had planned to introduce this in our China plant as a global blueprint. Yes, September 2019, the benchmark was more or less on the last mile. The only point what was still on our agenda open was the proof of concept. There we had a big why for help from a production site in USA. And there we were faced with the following situation. We had there a very low level of data acquisition and also data quality. There was no SAP ERP system in place, and also no manufacturing execution system. And also the industrial level of the machinery part was very inhomogeneous. So, and with this low level of data acquisition, also there was no really good KPI system in place. Traceability for sure was possible, but only with a lot of manual effort, and also quality analysis took a long time to fulfill the customer requirements, and this leads into complaints from the customers. And yeah, then we had the situation to deal with, and we said, okay, let's do it in a really unorthodox way to run a POC, because we had two possible suppliers, but no time for a POC. But we had a production site which had a really strong need for a professional solution. So we decided to run the POC not as a POC, we called it firefighting approach. And we said, okay, that company that's able to help us, they will win the race. So in both suppliers were able to meet our requirements, but only SAP was able to send a team of SAP consultants and also integration partner Systema to our production site in Hendersonville. And this team started immediately supporting our production. Yeah, but what was implemented and how? The first thing, if you want to set something live, is that you need a proper infrastructure. So, and under normal circumstances, it means you have to order servers, you have to bring them into your data center, you have to install everything, and this takes at least months. And this was for us not acceptable because we had no time to do this, to wait so long. And SAP offered us a really great solution by using the value prototyping environment. So that means we were able to set up a complete MRI stack within a few days. After that, we did a system copy of our productive ERP system, and we connected also this copy to this value prototype. So that means we had within 2 weeks a complete environment where we could start work with. Next step was that we connected the machines, at least from the main processes, and we did this within 4 weeks, which was for me really great, because with that speed we were able to hand over reporting and production KPIs to the production based on the SAP Analytics Cloud. Yeah, the benefit for us as the customer out of this firefighting approach was that we had first transparency on our production numbers, and also the order fulfillment, and also the quality could be increased based on analytics through this SAP Analytics Cloud. Yeah. After this firefighting approach was closed, we stepped into a normal waterfall project like it's usual during implementing huge solutions. And we did this in parallel to an ongoing SAP S/4HANA roll into this production site. And this was really challenging, but the main pain point, let's call it like this, was this different industrial level of our machine park, because this one-size-fits-all approach didn't work out for us. Let me explain this here in detail. Let's say it like this, our main process is the SMT process. So that means we populate parts on printed circuit boards, and these are then at the end of the day our final products. And we had here 2 different machine concepts. So we called them old and new SMT lines. Let's go through the old SMT line to show you the process. At first, we had there the so-called board loader, where we feed the raw boards into the process. Then on some machines, not on all, we had a so-called laser etching machine, where we mark all boards with a unique identifier. Then there is a solder paste printer. Means we print there the solder paste according product and customer specific parameters. Everything is checked then on a SPI. SPI means solder paste inspection. When we have a glue dispensing machine, and then starts the main process. This is the pick and place process, where the raw components are placed, populated on the boards. Everything flows then through the oven, and there the real soldering process happens. After that, we have their second inspection machine is the automatic optical inspection, where we check with pictures and pattern comparison, deviations in quality. And then we have their turnaround, and you see here, you see there the same processes like we had here the first run. So this is necessary because the boards are both sides populated. Means we have a mirrored side there, and at the end we have the depaneling, where we mill out the PCBA boards out of the huge panel, and everything is then tested in the testing station and packed on the packing station. Yeah, and you see here everything is like a flow, but this is only a physical flow because the machines are not talking to each other. They are only physically connected and not connected by data. And the second point, which was for us here not a blocking point, but a challenge, is that a lot of machines were not able to offer us an interface. And so we said, okay, let's focus on the main machines, the quality machines, where we can and have to ensure that our products are okay. This we connected, and to calculate, for example, in OEE, or to check is the order fulfilled or is there still something missing, we did a retrofit approach. Means between the processes like laser etching, DAC, SPI, we placed IoT devices. IoT devices with sensors, which are able to count board movements. So with this approach, we were able to count parts at the old lines. We could also count the cycle times. We could also see if there is machines downtime. And this was for us the basic for transparency for production. But still there was something open, because you also need scrap booking. So, and where it's possible to collect the data automatically, we did this also with failure codes. For all other processes, we offer the operators some pods. So that means user interfaces where they can book their scrap with failure codes into the system. The processes are more or less the same. So because this is product dependent, but the technology behind is totally different. The processes are horizontal and vertical connected. So horizontal means we have there a machine-to-machine connection based on the industrial standard protocol. This is used for closed loop controls. Let me give you an example. So if you have for a trend on the AOI, then the AOI will the pick and place machine, for example, directly feedback to adjust the parameters. So, and with this closed loop, you can hold your quality on a really high level. But we have also a vertical communication to our SAP ME system. So the machines are fully integrated. So that means each machine or all machines are connected. Let's start with an example here of the PCB loader. There you can see material check. So what is there behind? So if you want to run a production, then you're only allowed to use specific components. And if you choose a program and you try to check in the wrong component, then we interlock the machines. For the laser etching machine, for example, we said, okay, we take the logical logic out of the machines and we bring this to our central system, because then it's quite easy to copy the laser marking machines and ensure that you have still unique numbers. If you don't use this approach, then you have to ensure this locally machine to machine. For example, if you have there a printed board, so there we have a restriction that this is only usable for, let's make an example, 30 minutes. After that, the solder paste is too dry to ensure the quality. So therefore, we count the time starting the printing the paste, and if this time is over, then we also block the single parts. Okay, what else did we implement here? As I mentioned already, we have fully integrated all the machines and all the main processes to SAP ME/MRI, and we are able to interlock on SFC level. SFC is an operation from ME. Let's call it a single part, one piece. We also are able to ensure a full traceability chain to our customers. We are able to track moisture and time-sensitive. Moisture sensitive is something similar, but there you have other parameters. So for example, LEDs, if you open the dry package, then you are only allowed to use them for, I don't know, 4 hours, depends on the product. And after this, they must go into a special shelf to try again. NC failure code handling, this is also really helpful because we are able with this SAP ME system to build up a failure code hierarchy. That means you can cluster your problems, you can sort it out with this hierarchy, and then you can focus on special things. But the system is not a standalone system because, as I mentioned, we had also this integration of the SAP ERP system ongoing there in parallel. So that means this is also integrated into this ERP workflow, especially the extended warehouse management module and also PP. There we have a deep integration. For example, the automatic staging and consumption based on machine data. So it's not necessary that you go into the SAP PP module and typing in there, I had a yield 1,000 parts, I don't know, 50 parts. This is everything done automatically in the background. Also, tool management we have integrated, so that means tools are also part of our traceability, and we also can block parts according some special parameters like expiration dates. And packaging and label printing, I think this is state of the art. Yeah. Question is now, what was implemented differently to this normal, I would call it normal approach. First thing is we decided that our SAP ME and SAP MRI systems should not be on-premise. That means all servers are hosted by Microsoft Azure with the SAP HANA Enterprise Cloud. On-premise, we have only the so-called software. This is our, let's say, interface, our middleware between machines and the MES. Then we store more data than required by our customers. So, for example, we store mass data, like the raw measurement data, like pictures, like process data from the machines. And this is a huge amount of data, and we store them into a data lake based on SAP HANA services in the cloud. And yeah, storing data, you have to work with data, let's call it like this. So, and therefore we decided to use the third huge SAP topic, SAP solution there, the SAP Analytic Cloud. We use this for modeling, combining, and visualization of the data, not only from ERP, also from ERP, MII, and also the data lake. But let me explain this to you in this landscape. Hopefully you can see now my. No, I think it's not really working. Laser pointer. Ah, yeah. Okay, it's only an example here, the base. So because we have a lot of different machines with a lot of different interfaces, but here are 3 examples how this looks like at OSRAM Continental. So we have here, for example, IoT devices which are connected by the MQTT broker. We have old machines with locally running access databases where we developed an agent on the Pico to read this database out frequently. And we have also new machines with web services, means with real handshaking protocols. Yeah, this is, let's say, the base. So everything is connected to the SAP plant connectivity. So this is the server which is on premise. And this is also necessary due to latency issues. The heart of everything, what we did here, this is the SAP Manufacturing Execution and MRI stack. And as you can see here, it's cloud-based and it's hosted by Microsoft. And we only store there around about 20% of the data. All data we are able to collect, we store into this SAP HANA services in the cloud, means the data lake. And you can see here we also use there one additional component from Microsoft. It's the so-called Azure Data Lake component. It's more or less, I would say, a storage container where we store our mass data. So all the logic which is necessary to work with the data, this is part of the SAP solution. And we did this because the amount of data is really high. We are talking here about 14 terabytes per month. We have to store there and we have to keep there for months. Yeah, and the third thing, what I also mentioned already, this is this SAP Analytic Cloud. So this is our central reporting and KPI and business analytic tool. And you can see here, this is connected to each other system, not to the machine level. There we have no connection. It's only connected to the, let's say, HANA databases, because there it's completely integrated. So, and let me go to the next slide. Yeah, exactly. Yeah, conclusion. So what is the key takeaway? Yeah, for us, the key takeaway was, and still is, that stepping into the world of Industry 4.0 and smart factories only possible with a strong partner. And you need a partner which enables you with good ideas, with a good team, but also with smart and integrated solutions to improve your business. And this is what we found with SAP. What are the benefits? Yeah, it's totally clear. It's all about money, because with this current implementation, we are able to ensure that we can run and improve our business. So, and we are able also with the reports to give the transparency to the production, to combine data, to reduce costs, to increase the quality, to increase the output of production. And this is all cost saving, and at the end it's money. Any lessons learned? Yeah, for sure. We had a huge project, long-running project, and we had there a lot of lessons learned. But let me point out here my top 3. First topic was, and still is, that due to the COVID pandemic, we had to run this complete project remotely. So that means our team was located in Germany, and the customer, the internal customer, was and is in Hendersonville, USA. So it means you had their time zone issues, but you had also other issues, because you often have not been able to understand the real problems of the production, because you were not able to see it. This was really not helpful. And second thing, what we've learned, implementing new technologies as a first customer is a real challenge. So here I speak from the data lake. We had there a huge learning curve together with SAP to set this live and to make this run. At the end, yeah, it's running, but it was challenging. And for sure, connection to machines or connecting machines without an industrial standard of communication, this is time consuming and really expensive. So this is also what we've learned. The Pico software offers a lot of interfaces, but unfortunately, these interfaces are not used by our machine suppliers. So and there we were forced to develop special agents according to machine interfaces, which are offered by the machine supplier. So, and this was also time consuming and really expensive. Yeah, these are my top 3 lessons learned. So, and there I'm at the end of my presentation. Thank you for your attention. It was a pleasure for me to use the stage here and to present the project to you. And now I would like to hand over to Sebastian and to ask or to answer open questions.
Yeah, thank you very much, Andre. I hope that was an interesting session for everyone, and you gained some valuable insights into the MES implementation. As we said, we would be open for questions now. First question from the chat is, who was the second MES vendor you were talking to besides SAP?
Sorry about this, I will not answer here in this round. This would not be fair.
Then the second question is, do you have pick and place machines from ASM in use?
No, we haven't. We have ASM, or let's say a spin-off, DEC. I think DEC is a solar-based printing machine, which is a part of the ASM company. But for the pick and place machines, we used KNS, Kollege and Sofa. I think it's a German brand, and Tsuki. It's a Japanese brand, I think so.
Then a more technical question, which protocol were you using for machine-to-machine communication? I think there were some audio issues when you explained that.
Yeah, we used this. I'm not so technical. I'm not so deep technical there, because this is more or less something for our MTP department. but we used on the new lines the so-called Hermes Protocol. So this is an industrial standard, especially in the electronic world, to connect the machines in a machine-to-machine horizontal connection.
Then I think a very interesting question in regards to cloud about the latencies that we have and that you require, of course, as well for your production. Do you have a feedback regarding the latency?
Yeah, this was also something where we had a lot of doubts. Will this really work out? And we used the following approach. So we use the nearest Microsoft data center to the plant. So that means we try to reduce the distance between the data center and us as a customer. So with this reduced distance, you also reduce the latency. This is clear because this is a linear. Yeah, but again, what we also did, we used the so-called express route technology. So that means at the end, it's a dark fiber connection. We have a dedicated line to Microsoft Azure. So, and therefore we are able to have a huge bandwidth with a low latency. So we are talking here about 20 to 30 milliseconds. And this is more or less like you have the server on site.
Then a question towards IT budget. If you have any information about the comparison of this new IT budget now with the solution compared to the previous budget.
Previous budget means?
Well, I guess without the MES, or if Hector Garcia, who asked the question, would like to speak up, he can explain it a little bit better.
You may unmute yourself if you'd like to speak by clicking the microphone.
Thank you for the opportunity. Yeah, Andreas, meaning what was the cost of the solution in terms of the previous cost of operating your production site?
I could tell you not the details because this is not allowed. So what I can say is that we had a good or that SAP offers us a good license model. So for example, you have not to pay there for connections, for users, for, I don't know, for machines. You pay this one time, this license MRI and ME for the size of your location. So, and I think, Sebastian, correct me if I'm wrong, there are 3 options: small, medium, large, if I remember right. And we are a small plant that's up to 500 users or something like this. And with this and a good discount, we could keep the costs really low there. What was the cost driver? Maybe is to explain you this. This was the machine connection for sure. So because as I mentioned, we had to adapt a lot of different machines due to this inhomogeneous machine part we have to ME. But this is also a one-time cost. So that means if you run the approach that you have one brand you used to buy, let's take ASM as a good example, then you develop this interface to this machine one time. And then you can reuse this as much as you want, as often as you want. So that means it's not quite easy to answer you the question. So the first effort is a high effort, but if you consider then the long running costs, it's quite low.
Then about the EWM integration, which objects are integrated to EWM?
Yeah, I'm not the totally EWM expert. So, but what we did is the complete staging integration. So, means for us, normally you have in production your production storage areas where you have to ship your parts from the warehouse to production. And this we did completely in the interface. So that means the production planner plans a shop order. So if you then in ME, in SAP ME, decide to start the production order, or it's scheduled, it's also possible, then automatically this information is flowing back to EWM. So that means then the complete workflow starts. So that means printing out, picking lists, inform the user or the operator in the warehouse that they have to pick the components, preparing the kits, driving the picks with the truck to the production site. All this workflow is then started in the background. So, and also vice versa. So if we have more, or if we have leftovers in production, it is also usual that this happens. So that means we have components on reels. So if you don't use the complete reel, then you bring this back to the EWM, to the stock. So, and also there we have an interface which enables us to bring parts, components back to stock. Or other integration, when we print out, for example, and or when we pack products into totes and we close the tote, then we also book this into EWM and we create their stocks.
Then are you able to share some information about the return on investment for the new MES?
It's quite hard. It's quite hard. Because as I mentioned, so the one-time effort is really high. So, and the return of investment we haven't calculated, because this is also something what was a lesson learned. We run there a little bit longer than expected due to some COVID situations in Hendersonville, due to travel restrictions and so on. And therefore, the complete project ran longer than expected, and also this was impacting the return of investment. So, but if you want to have now a number from my, for me, this return of investment is within 3 years. This I cannot tell you right now.
Then a question, if you would be sharing your contact details between ME users, or if you're maybe engaged in some user groups or so.
Why not? For sure. I'm quite open. So the only thing what I cannot share is prices or something like this. So this is strictly forbidden. It's clear, but experiences, why not?
Then Chris, how is it done? Can the audience somehow get that, or shall Andre put his email in the chat here, or how is it done?
He's welcome to put that in the chat if he'd like, yes.
Okay, perfect. And then I think we have a last question, Andre. Which storage system do you use for the real storage, and if there is splitting and splicing functionality?
Okay, let's go through your question. So splitting and splicing functionality is, yeah, there is a functionality in SAP ME, but this is not really what we want or how we as a customer are used to work at Hendersonville. And therefore our integration partner Systema develops currently additional plugin, a tool where we can split and splice reels. So second point of the question with the storage, I did not get right. So maybe you can repeat this or give me more details.
So my question is regarding storage systems which you're using, like automatic storage system, a dry tower storage system, or Cardex, etc.
Okay, now I got your point. yeah, let's say it like this. We have normal storages, so that means shelves. So, but we have for special parts like MSL components, there we have special dry shelves. It's like, yeah, I don't know exactly if you know them, mega tower. So that means it's a huge, like a machine. It's not like a storage, and this is a computer supported. So that means you put there your parts in, and the shelf itself did all the magic then in the background, checking how long is the part in, controlling the FIFO approach, checking the moisture sensitive level. And also this machine we connected due to this moisture sensitive requirement from our customer. So that means we have both. We have normal shelves, which are more or less EWM controlled. We have shelves in production where, let's say, the parts for the running and also for the next order is stored. And you have some intelligent shelves like this machine for moisture sensitive part components.
Okay, so I guess we have to wrap up now. Thanks everyone. Thanks Andre for your time.